Okay, here we go with our parallel circuits worksheet. We're going to go ahead and do number 2 and point out some of the differences between the parallel and the series circuit as we go through this. We're going to start by calculating the total resistance of the circuit. Now remember, in series you would simply add the 50, the 20, and the 6 all together and get 76. But here in parallel, remember, we are talking about the inverse resistance rule. So what we have is 1 over our total resistance is going to be equal to 1 over 50 plus 1 over 20 plus 1 over 6. And that is going to give us our 1 over the total. So let's figure out what that is. So we have this is 0.02. This is 0.05. This is 0.16. Now this is an important part. You have to remember that these add together, and then 1 is divided by this total. So this gives us 1 over, we add these together, we get 0.23. So 1 divided by 0.23 is going to give us 4.35 ohms. That is our total resistance for the circuit. So the next one we want to do is calculate the current of the circuit. Well, the current of the circuit, we know from Ohm's law, is going to be I, which is V over R. We know the voltage from the problem, 24 volts. We have the resistance, what we just calculated, 4.35. This is going to give us 5.5 amps. Okay. The next one, it talks about the power dissipated by the circuit. Well, power, we know, power is equal to current times voltage. So we just figured this out. We have 5.5 times our voltage, 24, which is going to give us 132. Now we have the current in each resistor. Remember that the current in each resistor will change on the resistance in each of those branches. So let's figure that out. We want to do current in each resistor. So we're back to our original formula. So we know that current is going to be equal to voltage divided by resistance. Well, let's take a look. Does the voltage change? No, that's the key to a parallel circuit. The voltage stays the same. So we have 24 volts for everything. We now divide that by our individual resistors, 50, 20, and 6. And we get 0.48, 1.2, and 4. Those are going to be the currents in each of those branches. Now the voltage drop in each resistor is what it is. It's the same for all, 24 volts. So 24 volt, because it's a parallel circuit. And then the power dissipated by each is simply going to be the current times the voltage. Well, we know the voltage is the same, right? 24, 24, 24. We calculated our currents right here, 0.48, 1.2, and 4. Multiply these together. You're going to get 11.52, 28.8, and 96. And the power of each individuals will add up to be pretty close to the power of the circuit. And for those of you who have made it this far in the video, the magic word for the day is chamba. We love the chamba.